Let's look at lesson 2.5. In this lesson, we introduce imaginary and complex numbers. So, quick review. Last lesson, we talked about rational numbers. And rational numbers are anything that can be written as a fraction. So, things like 3/2 or 1.3 repeating. All of those can be written as fractions. Then we have irrational numbers, which are numbers that cannot be written as a fraction, things like pi or square root of 2. If we take rational and irrational numbers together, we get the realm of real numbers. Now, if it's not a real number, that means it cannot be written as a decimal. We also have the imaginary numbers. So imaginary numbers are anything that have I, which we have right down here defined for us. I squared is -1. So that means I is the square root of -1. So that is how we define our imaginary number. If we combine our imaginary and real numbers together, we get something that looks like this, A plus BI, where A is the real number and BI is the imaginary number. So if we put a real and an imaginary number together, that forms our complex numbers. So those are all the different kinds of numbers that we have in mathematics. So, and that defines pretty well what our imaginary numbers are. We have I squared is -1, so I is the square root of -1. We also have this defined right here if we have the square root of a negative number. So if I have like square root of -7, that is the same thing as square root of 7 times I. And that's something we're going to use right here when we're going to simplify some complex numbers. So let's talk about simplifying complex numbers. In this first one, A, we're subtracting. With subtracting, don't forget that it is still important to distribute the negative. So I have 1 minus 2i minus 3 minus 4i. And at this point, it's just combining like terms. -2i minus 4i is -6i. 1 minus 3 is -2. Notice I put my real part first and then my imaginary part, just like we had up here, A plus BI. A plus BI, A plus BI. Okay, let's try multiplying. So what I want you to do is pause the video, try to FOIL this out on your own, and don't forget in your foiling and simplifying that we know that I squared, there it is, come back, is -1. So when you FOIL all this together, you should get an I squared. Don't forget to change that to a -1. So pause the video and try FOILing this one out on your own. Let's check what you got. So I had 1 times 3 first is 1 times 3 is 3. 1 times 4i is a positive 4i. -2i times 3 is a -6i. And -2i times 4 is a -8i squared. So the 4 and the -6 gives me -2i. I turn my I squared to a -1. -8 times -1 is a positive 8. And 3 plus 8 is 11 minus 2i. So there's FOILing some complex numbers. Now let's talk about dividing complex numbers. Dividing complex numbers is very interesting because we're not actually really going to do any division. We are actually going to multiply by what we call the conjugate. The conjugate is where the middle sign changes. So we are going to multiply by the conjugate of the denominator. So I take this denominator, I have 3 and 4i, and then I'm going to change the middle sign from a minus to a plus. That's a conjugate. You change the middle sign. And it kind of creates a difference of squares. We're multiplying with a plus and a minus. Now, because I multiplied by that conjugate on the bottom, I had better multiply by the same conjugate on top. And we're going to FOIL all this together and see what we get. So on top, 1 times 3 is 3. 1 times 4i is 4i. Negative 2 times 3, negative 6i. Negative 2i times 4i, negative 8i squared. Should look kind of familiar. On the bottom, 3 times 3 is 9. 3 times 4i is 12i. Negative 4 times 3 is minus 12i. And negative 4i times positive 4i is negative 16i squared. So if I go to simplify this, my 4i minus 6i is negative 2i. My I squared becomes a negative 1. Notice on bottom, your middle two terms cancel. And that will always happen with a conjugate. With a conjugate, your middle term goes away because of that plus and minus. And then I have minus 16 turn my I squared to a negative 1. So this becomes 3 plus 8, 11 minus 2i. This becomes 9 plus 16. Two negatives make a positive. 9 plus 16 is 25. And then the last step is we're going to divide both of these by 25. And we end up once again with an answer in the form a plus or minus bi. And that is how we divide complex numbers. You always multiply by the conjugate, FOIL everything out, and simplify it. Let's go over here to this one. If you remember back up here, when we did the square root of the negative 7, we said square root of negative 7 is square root of 7i. That's what we're going to use right here on D. So square root of negative 3 is the square root of 3i, times square root of negative 12 is the square root of 12i. So square root of 3 times square root of 12 is square root of 36. I times I is I squared. Square root of 36 simplifies to 6. I squared is negative 1. So we get negative 6. Sweet. Let's move on to the next one, E. This time our negative 3 and negative 12 are inside the root, so we do them first. Negative 3 times negative 12 is positive 36. Square root of positive 36 is 6. Notice that D and E look very similar in the beginning, but they do have different answers. Last one for this one. Notice that once again I have conjugates here, 1 plus 2i, 1 minus 2i. You do need to FOIL these out. So what we're going to do is start off by distributing my negative here. So I have x minus 1 minus 2i. And distributing here, I have x minus 1 plus 2i. Conjugates are still there, 1 minus, 1 plus. And we need to FOIL this together. Now, you could do this with our rainbows, where you'll end up doing rainbows 3 times. Or, if you get confused with the rainbows and get lost and make little mistakes, I highly suggest you think of doing it in a box form. You will get the same answer, but you'll make far less mistakes. So in this box form, I'm going to put my first one, x minus 1 minus 2i, and my second one down the column, x minus 1 plus 2i. And now we're going to multiply our boxes together. X times x is x squared. X times negative 1 is negative x. X times negative 2i is negative 2ix. Negative 1 times x is negative x. Negative 1 times negative 1 is a positive 1. Negative 1 times negative 2i is a positive 2i. 2i times x is a positive 2ix. 2i times negative 1 is a negative 2i. And 2i times negative 2i is negative 4i squared, which I squared is negative 1, so that's really just a positive 4. Now, this is your answer. We just need to put it all together. So we have x squared minus x minus 2ix. Go to the next row. Minus x plus 1 plus 2i. Go to the next row. Plus 2ix minus 2i plus 4. And that is the same thing you would have gotten if you had done all of these rainbows. This is just a different way to organize your work and think about it. Now, if I look here, I have a negative 2ix and a positive 2ix, a positive 2i and a negative 2i. So I have x squared minus x is minus 2x, and plus 1 plus 4 is a plus 5. So all this boils to right there. So that is some basic simplifying of complex numbers, subtracting, multiplying, dividing, FOILing, all that good stuff. And down here you do have your definition of your conjugate. We'll commonly use this little bar right here. That bar means conjugate. And that just means you change the middle sign from whatever it is to the opposite sign. So that's some basic complex number stuff. In the next video, we're going to actually go back to what we were doing in 2.4 and look at finding zeros again.